Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. I am going to arithmetic operation. Now we are going to start arithmetic operator. Okay. So what are arithmetic operator? Like binary operator you are having, plus, minus, the mod operator you are having. So the binary operators that you are having, the binary arithmetic, the binary arithmetic operators, the binary arithmetic operators are multiplication, divide, plus, minus, and the modulus operator, and the modulus operator. Okay, you are having a modulus operator. So that is represented by this. You know that. So integer is going to truncate any fraction part. Integer is always going to truncate the fraction part. Integers, integer, integer division truncates truncates any fraction, any fractional. So one thing, just let me write before, just in declaration. Two things is required. So after that, in declaration, I will explain. Okay. So you have seen that integer division truncate any fraction. Like example, if I'll write x equal to 5 by 3, so the if you'll print x, will print x, it will give output as 1, because it is going to be 1 point something, but it will truncate the fraction part. Now the expression. Now we will see mod operation. Now we will see the mod operation, the modulus, the expression x mod y, the expression x mod y produces the expression x mod y produces the remainder. It's going to produce the remainder. It's going to produce the remainder when x is divided, by y. When x is divided by y, it will give the remainder. Okay, and thus is 0. Thus is 0 when y when y divides x exactly. When y is going to divide the x exactly, then it is going to give the remainder as 0. Okay. So now we will write a loop, like you take an x equal to 5 mod 3. So here you will get as 2, because remainder is going to your 2. Okay. Now something is there, that mod operation cannot be applied in float and double. The mod operation cannot be, the mod operator cannot be, you are not allowed to use mod operator, cannot be applied to float and double. Float or double, you are not allowed to use. Okay. Now if you are using plus and minus, if in mod operator some operation is plus, some is minus, if numerator is positive, denominator is negative, then what is the resulting sign? It is machine dependent. It's very important. The the direction of the direction of truncation, for divide, and the sign, the direction of truncation for divide, and the sign of the result, the sign of the result, for mod are machine dependent, is machine dependent, for negative operand, it's a machine, as is the, okay. So now see one code on, so it's, so if numerator is positive or denominator, so is machine dependent, okay. Now see one code, leap year code, leap year. Check whether a, write a program to check whether a year is leap year or not. Write a program to check, whether a, write a program to check whether a year is, leap year, whether it is a leap year or not. You need to check. Then how you can check it? You know that a year is, see, a year is leap year if it is divisible by 4 but not divisible by 100. Okay, if it is divisible by 4 but not divisible by 100, or if it is fully divisible by 400. Okay, so if it is divisible by, means it is having two conditions. If year is divisible by 4, there we will use is equal to 0, and year is not divisible by, okay, it should not be divisible by 100. This is one condition. This is one. If year is divisible by 4 and year is not divisible by 100, or this is logical, or if year is divisible by 400, then it is a, leap year. Then printf that whatever year they have given, percentage d is a leap year. Okay. Else you will say printf. Please let me know whether it is clear or not. Percentage d is not a year. So since percentage d you have written, it will take year from here. So write a program to check whether a year is leap or not. What you will do, you will check. So when you can say that a year is leap year, if it is divisible by 4 and it is not divisible by 100, then it is a leap year. Or if it is divisible by 400. So there we are going to use the mod operation. In this way we are going to use the mod. Okay. Now we are having the binary plus and minus. They have the same precedence, means if we are having precedence table, I will give at the last. We are having plus and minus. Then if you are having like a 5 plus 3 plus 3 minus 2, so both is having same precedence. So either you perform this or this, it's okay. So either you can do like this or you can do like this. Answer will be same. So if you'll do, then 8 minus 2 is your 6, and here 5 plus 5 minus 1. So plus and minus is having a same precedence, which is lower than the precedence of multiplication, divide, and modulus. So right. So arithmetic operator is going to be finished. The binary plus and minus operator, the binary plus and minus operators have the same precedent. It is going to have the same precedence, which is lower, than, the precedence of, is lower than the precedence lower than the precedence of, which is lower than the precedence of Precedence of star, divide, and mod. So which in turn lower than the unary plus and negative, which is in turn lower than unary plus and, okay. So it is going to be lower than unary plus and minus. So what is unary plus? Like int a equal to plus 5, it's a unary plus. Int b equal to minus 5, it's a unary minus. Just one symbol. It's a unary plus, it's a unary minus. Okay. So it's less than. So associativity is left to right. Okay. Arithmetic operations means if you are having uh, 1 minute. So let me write operators associates left to right. So first you will do the left operation, then you will do the right operation. First you will do the left operation, then you will do the right operation. Arithmetic operators associate left to right. It will do the execution from left to right. Example, if you are having A into B into C, you should do A into B, then you can do, after that you will get some result, latest in D, then D into C. So in this way you can do, because even the precedence of this is same because both is having plus. So or you can you change it as a divide, then it will be more clear. If I'll make it as a divide, then it will be more clear. So then it will execute like this. So because both is having a same precedence, so multiplication and divide is having a same precedence, and associativity. So if whenever if these two are coming which is having a same precedence, so multiplication division is coming is having a same precedence, so you will execute from left to right, same precedence is having, then whenever same precedence, then you will go to associativity, so whether to go left to right or right to left. So if you are having 5 3 mod 2, okay, so I should make its divide, it will be more easy. Make it as divide, okay, just divide, make it as divide. So you, how you will do, you will first do 5 into 3, then with the resultant you will, sorry, then in the resultant you will divide it with 2. In the resultant you will divide it with the resultant, it will divide, so 15 by 2, it will be 7.5, so that is going to be 7. Okay, so this way you have to execute. So don't do first this, because if you will first execute this, then answer will be wrong. Okay, if you will first do this 5 into 3 by 2, then it will be 1.51, then 1, so it will be wrong, so if it is having a same precedence, then you go to the associativity, that its associativity is left to right, you go to left to right. Okay, so that we have seen arithmetic operation. Now some part is remaining for declaration, that constant part that I have told you that I will teach you, that in declaration when you will use the constant, in declaration when you will use the constant, in declarations when you use the constant, okay, when you use the constant, so the qualifier constant, because rest you know I have taught you. So the qualifier constant can be applied, the qualifier constant can be applied to the declaration, to the declaration of any variable, to the declaration of any variable, to specify to specify that to specify that its value to specify that its value will not be changed. Its value will not be changed. So the qualifier constant can be applied. We are applying the qualifier constant to the declaration of any variable to specify that its value will not change. Its value will not change. Okay. Okay. So the qualifier constant can be applied to a declaration of any variable to specify that its values will not be changed. Example, you are saying constant double E, which is having 2.718281 like it is having some big number, it means that its value will not be changed. Okay, now next, now if we'll use for an array for an array the constant for an array the constant qualifier says that the element will not be altered. The elements will not be altered. Will not be altered. Okay. Example, if you are having a character constant, so for an array, the constant qualifier says that the element will not be altered. So you are not going to alter means changed. Altered means changed. Okay. So you are not going to change its value. So if you are having a const char message equal to warning, not going to. So this was just remaining in the declaration.